Hello everyone, this is Teacher Kathy and this is part 2 of the Exponential and Logarithmic Functions.
Our fourth example states, find the value of the following. Logarithm of 38 times the cube root of 96 to the base 10. Number 2, the logarithm of 384 to the base 2. You are given the following hint, that is, your 384 equals 4 times 96. Also given are as follows. The logarithm of 2 to the base 10 is equal to 0.3010. The logarithm of 38 to the base 10 is 1.5798. And the logarithm of 96 to the base 10 is equal to 1.9823. Now here's the solution for the logarithm of 38 times cube root of 96 to the base 10. The logarithm of 38 times the cube root of 96 to the base 10 can be rewritten as the logarithm of 38 to the base 10 plus the logarithm of the cube root of 96 to the base 10. Now, the logarithm of the cube root of 96 to the base 10 can be rewritten as 1/3 times the logarithm of 96 to the base 10. Because we already have the value for the logarithm of 38 to the base 10, which is equal to 1.5798 given earlier, and we also know that the logarithm of 96 to the base 10 is 1.9823, then if we add 1.5798 plus 1/3 times 1.9823, we have 2.2406. For the solution of number 2, we have the following. The logarithm of 384 to the base 2 can be rewritten as the logarithm of 4 times 96 to the base 2. This is because 384 can be rewritten as 4 times 96. The logarithm now of 4 times 96 to the base 2 can be rewritten as the logarithm of 4 to the base 2 plus the logarithm of 96 to the base 2. That is, because we can rewrite 4 here as 2 squared, we have the logarithm of 2 squared to the base 2 plus the logarithm of 96 to the base 2. And this is equal to 2 times the logarithm of 2 to the base 2 plus the logarithm of 96 to the base 2. Now let me just pronounce the logarithm as log. So we let y be equal to the log of 96 to the base 2. By definition, we can rewrite this equation as 2 to the y equals 96. If we take the common log, we will have the logarithm of 2 to the y to the base 10 equals log of 96 to the base 10. And solving for the value of y, we can rewrite this as y log of 2 to the base 10 equals log of 96 to the base 10. Separating values and solving for y, we have y equals log of 96 to the base 10 divided by log of 2 to the base 10. Also, from this equation, we have y equals 6.5857. Now, if we take a look on the fifth line above here, we can rewrite now the logarithm of 384 to the base 2 as 2 times 1, because the logarithm of 2 to the base 2 is 1, plus the logarithm 96 to the base 2, which is equal to 6.5857. That's now equal to 8.5857. Remark 1 is on natural logarithms. The natural logarithms use the constant e, which is approximately equal to 2.7182818 as its base. The natural logarithm of x is usually denoted by ln of x. On the other hand, the common logarithms use 10 as its base. Remark 2. If we remove the base b, or if b is omitted, then it is assumed that the base is equal to 10. Observe also that the logarithm of 10 to the k times n minus the logarithm of n, because this is a minus here, is equal to the logarithm of 10 to the k times n over n. But this can be rewritten as k times the logarithm of 10. But because the logarithm of 10, understood that it has a base 10 here, is equal to 1, then this is now equal to k. The logarithm of 10 to the k times n is also equal to k plus the logarithm of n. The following are the exercises. The answer to these exercises can be found on slides 9 and 10. We now try to solve the following equations. Solve for x in the following equations. 3 to the x plus 1 is equal to 27 raised to the x. 8 to the x squared minus 1 is equal to 4 raised to the 4 times x. Let's solve for the following equation. 3 to the x plus 1 equals 27 to the x. But 27 can be rewritten as 3 to the third power. So that 27 to the x is equal to 3 to the 3x. The exponent x plus 1 therefore is equal to the exponent 3x. And transposing x on the other side, we will have 3x minus x is equal to 2x. Equals, the other side we have 1. Solving for x now is equal to 1 half. Therefore, the solution set equals the set containing 1 half. Solution for number 2. 8 raised to the x squared minus 1 is equal to 4 raised to the 4x. Now 8 is equal to 2 to the third power. So that 8 to the x squared minus 1 is now equal to 2 to the 3x squared minus 3. On the other hand, 4 to the 4x is now equal to 2 to the 8x, because 4 can be rewritten as 2 to the second power. Hence, 3x squared minus 3 is equal to 8x, meaning to say, this exponent 3x squared minus 3 is equal to this exponent 8x. That is, if we try to transpose 8x on the other side, we will have 3x squared minus 8x minus 3 is equal to 0. This can be factored out to come up with 3x plus 1 times x minus 3 is equal to 0. And solving for x, we will have x equals negative 1/3. And solving for x on the other factor, we have x equals 3. Therefore, the solution set is negative 1/3 and 3.
Example 2. Solve for x in the logarithmic equation. The logarithm of x plus 1 minus the logarithm of x equals the logarithm of 12. The log of 3x plus 1 to the base 2 plus the log of x to the base 2 equals the log of x plus 3 to the base 2 plus 2.
Not everything that can be counted counts, and not everything that counts can be counted.